Myself Bhagyalakshmi, dependent of mathematics, working as an assistant professor, KSR College of Arts and Science. Introduction to statistics. There are three kinds of lies: diamond lies, and statistics. This was described by Benjamin Disraeli. How to lie with statistics, how to lie without statistics. Next one. Why we are studying statistics? Data are everywhere. Statistical techniques are used to make mainly for decision purpose. And then the third point is no matter what your career, you will make professional decisions that involve data. Professional decisions also involving data. This point shows that only. And the next point, an understanding of statistical methods will help you make decisions effectively. Next one. There are few applications we are applying statistics for business fields. Application of statistical concepts in the business world. First, the finance, correlation and regression, index number, time series analysis. In the marketing purpose, we are using hypothesis testing, chi-square test, non-parametric statistics. In the personal, hypothesis testing, chi-square and non-parametric tests. Operating management, in this purpose we are using hypothesis testing, estimation, analysis of variance, time series analysis. What is statistics? These are the definitions. Statistics means we are collecting some data and organizing, we are presenting and analyzing and finally we come to interpreting data to assist in making more effective decisions. And statistical analysis used to manipulate, summarize and investigate data so that useful for making decision purpose and analytic purpose. Next one. This image shows a statistics, a bunch of number looks for a fighting. So, this is an example to show the image. There are few types of statistics, descriptive and inferential. What is descriptive? Descriptive statistics methods of organizing, summarizing and presenting data in an informative way. Which are the countable one? That comes under descriptive statistics. Inferential means this method used to determine some analytical like population, overall population. On the basis we are in the population itself, we are taking some samples. That is the inferential statistics. Population, the entire set of individuals or subjects of interest or the measurement obtained from all individuals or objects interested. The particular subjects in the subject population, we are the population we are taking the sample. Next, these are the example. See, there are some different types of cause and colors are there. The overall population items. In that we are taking some samples. See, there is some black color one. In the black also some difference are there. We are taking 3 samples. In the empty color car, there also some 3 types are there. In that also we are taking 3 samples. This is the inferential one. In the analytical field, we are using the inferential statistics. Next one. Inferential statistics. In the estimation, see the diagram. Estimating the population mean weight using the sample mean weight. The person also having the same weight. In the same line, the last one previous, that person also having the same weight, but we are comparing. But in the hypothesis testing, we are comparing the population mean weight. Example, 70 kg, all the person having 70 kg, in the 70 kg we are comparing. Next, sampling. A sample should have the same characteristics of the population is called sampling. Then the sampling we have with replacement and without replacement. And with replacement, a member of the population may be chosen from one speaking. See, suppose we have in the bowl of candy, we are taking up one chalky, that is called with replacement. Without replacement, a member of the population may be chosen only once. Suppose we are taking the lottery method, we are taking only one lottery, that is called without replacement. Sampling methods. Sampling methods can be random, non-random. In the random, each member of the population has an equal chance of being selected. Randomly we are selected from one, that is called random sampling. Non-random means the actual purpose of sampling causes sampling errors. For example, the sample may not be large enough or representative of the population. Factors not related to the sampling process causes non-sampling errors. Why are we mentioning error means some defectives are there means that is the last point. A defective counting device can cause a non-sampling error. Error means some defective products are there, that is come under non-sampling error. Next, random sampling methods. Simple random sample, stratified sample, cluster sample and systematic sample. Each sample of sample size has an equal chance of being selected, that is a simple random sample. And the stratified sample, in the population we have some groups, in that groups we call strata, and the strata we are in the particular strata we are divided into each stratum, that is called stratified sample. And cluster sampling, we are divide the population, we are dividing and then into strata and then randomly we selecting some strata, that comes under cluster sample. And then systematic sample, randomly selecting a starting point and every nth piece of the data, that is called systematic sampling. Next, descriptive statistics. We are collecting data, that is example survey. In the survey method we are collecting data and then present data. Example tables and graphs, in the upcoming slides we can see some graphs and bar diagrams are, and summarize the data. We are using the sample mean formula, summation xi divided by small n. Next, statistical data. What are the methods we are using to collect the data? That's in this slide. The collection of data that are relevant to the problem being studied in commonly most difficulty, expensive and time consuming part. There are two methods, primary and secondary. Primary we are using questionnaire data and which are the real relatable data, that is come under primary data, and the secondary with the already we have that is the data we are taken. Next, data. In the data we have qualitative and quantitative, two types there. Qualitative means data measurements that each fail into one of several categories. Example hair color, ethnic groups and other attributes of the population. Quantitative means which are the countable one, that is come under quantitative. This image shows the one person is taking the data, the other person is giving the data to him. That's the thing this image shows. I do not know how to do statistics, but it does not matter without data, that is the image shows. Next one, there are some data representations there. The question is said allies whether you can make words means so many different things. In the words itself we can do so many different wording like Humpty Dumpty, that is also we can do with data representation. Next slide. Numerical presentation of qualitative data. There are, we can use pivot table and contingency table. In the contingency table, qualitative statistical attributes from which at least one of them is polynomial. Polynomial is 2 to more than, that comes under polynomic. Next one, frequency distribution, numerical presentation of quantitative data. In the frequency distribution shows the frequency number of occurrence in several categories that are used to summarize large number of data values. When raw data are measured at quantitative scale, either involved in a rational or categorical cases, that is the thing. Next one, steps for constructing a frequency distribution. First we have to determine number of classes, that is a formula m is equal to root of small n. Determine the size of each classes, we are taking the largest value minus smallest one, that is maximum minus minimum divided by number of m class intervals. Determine the starting point of the first class. Third point, tally the number of values that occur in each class. Each class is a class interval. Prepare a data table of the distribution using actual counts and a percentage of relative frequencies. In the frequency table itself. Next one is absolute frequency. In the Excel we can, how to do frequency table means, in Excel first we have to enter the data and then data type. In the data type we go to data analyst table, that in the left corner, and then go to histogram. If we click the histogram, we get the frequency cumulative frequency distribution that shows the total number of occurrence below and above certain keys. Cumulative frequency, usually we use the notation CF. Here we are I used NI, and cumulative relative frequency, and there are some charts and graphs there. Frequency distribution are good ways to present essential aspects of data collections. Next, first we are going to see the histogram. In the histogram, frequency used to graphically present the interval, ratio and class interval. We are comparing the class interval and different ratios. Next, see income. Here the x axis income in thousands of dollars, and frequency. This is the example of histogram. Its first thing is gradually 5% and it's increased 17 to 15 range, and then 20 to 25 is gradually increasing. It's a histogram. And frequency polygon. Another common method of graphical representation is a frequency. We can see the next slide in the frequency polygon curve. See, it is gradually increasing. These are the methods. With statistics we can help different kinds of graphs and bar charts. Next one is octave gauge. Octave gauge means with using cumulative frequency, whether you are giving the frequencies from largest to smallest to largest. A graph of cumulative frequency distribution. Octave gauge is used to want to determine how many observations lie below interval and the above interval. First, cumulative frequency distribution is the frequency which frequency first one only we are going to take the cumulative frequency. Cumulative frequency are plotted in the upper class limit of each category. Octave gauge can also be constructed for relative frequency distribution. We can use for relative purpose also. Next one. See, it is gradually increasing. Octave gauge never come down. It's always increase only. Next, pie chart. Pie chart we can see we are separating some interval marks and all. We can use pie chart. See, there are some different expenditure, wages, raw materials. We can easily split and identify. That is the purpose we are using pie chart. And bar chart. Actually, previous slide we can see the histogram. This is the bar chart. In the bar chart, we have to differentiate some particular years. We can identify in particular year how many rainfall. That's all. That's purpose also we can use bar charts. Here they are identifying, differentiate the colors. They used a bar chart. In the time series graph, the time series graph is a graph that have been measured over time. Horizontal axis represent the time periods, and vertical. In the time series we are using for weather forecasting purpose. We can use the rainfall data to represent the time series graph. See, suppose we have the how many rains in the 1961 to whether we in 1988 how many the weather is particularly changes. So, compared to here 2021 gradually rain and summer and winter are differently changing. So, that purpose and all we are using time series graph. And come to the conclusion, what I do when a teacher says this cannot be done night before. So, we are collected from the student data, take it at some students take it as a challenge. They are giving so many percentage. These are some examples to show the pie diagram. Thank you.